Okay, let's get this thing started. Hi everyone, my name is Anthony. Welcome to Own Your Data. This is an introduction to sort of open source protocols, security best practices. It's just, the idea is to help get you oriented to things like Linux, the dark web, and just generally tools that are quite useful, but I think maybe a lot of people aren't using, including myself. Here's some of the common terms and phrases you might have heard: open source, peer-to-peer, Linux, BitTorrent, encryption, and we'll make all these slides available for everyone as well at the end of it. But take as many pictures as you would like. So this is kind of the stuff we're going to cover. I'm going to talk fast. If you have any questions, just raise your hand, let me know. Sometimes, I might not talk quite as effectively as I would like, so just let me know if you have a question. Okay, so my background, electrical engineering. I've mostly focused on hardware, doing semiconductor manufacturing. I've had kind of a very minimal focus on code until I started getting into Bitcoin a few years ago. And then I realized, like, wow, I really need to up my level on these different protocols. So that's when I started learning about open source and trying to improve my security and my privacy on the internet. So these are the reasons that you would participate. First of all, it's free, right? These are free operating systems. So usually you pay for Windows or you pay for Mac. You pay for the software that you use, but open source is really cool because it's completely free to use. And in a lot of cases, they're unique tools that you wouldn't actually get in a proprietary model. And of course, freedom of expression, freedom of association. Like Bitcoin, for example, is an open source protocol. And that gives us a lot greater level of freedom of expression over our dollars, right, over our currency. The other thing that I'm really into is open technologies for humanity. I really want people to be able to access the technologies that we have and for everyone to be able to review them and use them. As anarchists, maybe we don't quite like the idea of patents and copyrights, and maybe there's something a little bit wrong with that system. But instead of fighting against that, maybe we can create our own new systems which are open source and available for everybody. To really sum it up, I prefer to control my software rather than my software controlling me. It's a really good way to summarize it. So what does open source even mean? The term that you'll hear is free and open source software, which means that the code is publicly distributed, it's transparent. GitHub.com, for example, is a really common repository of open source code. It should be free to download, use, modify, and you can even charge people for your modified version of it under some licenses. You should be able to verify that what you downloaded is exactly the same code that the other party created. And you do this with things called digital signatures and asymmetric encryption. I'm sure you guys are into crypto, so you've probably heard of a digital signature. We'll talk a little bit about what that actually means. So open source is governed under various different types of licenses. So just know when someone's using the term open source, it could mean a lot of different things. So usually you're going to want to dig a little bit deeper and say, okay, what kind of open source is it? There's a lot of marketing hype in that as well, where people are saying, hey, our product's open source, but in reality, maybe not all of it's open source, just a little bit. So know that that's kind of a buzzword, a catchphrase. Let's see. Okay, so far we talked about software, open source software. There's also this concept of open source hardware. In other words, the manufacturing process is more transparent. You can actually see the schematics of everything that's going on. And you have to keep in mind that all software runs on top of the underlying hardware. Unfortunately, the open source hardware market is still somewhat immature. Certain components and firmware are becoming more open, and there are even companies that are trying to build laptops that are totally open source. But we have a long way to go. But the software tools is really what we're going to focus on today. Okay, so the other term you'll hear is open source versus proprietary. Proprietary just means that it's held privately by a corporation, typically with some kind of copyright or patent involved, and enforced by the government. So open source versus proprietary, there's always trade-offs. People will say, well, which one's better? And usually the answer to questions like that are, it depends. So we'll talk about some of those trade-offs and the cases that you'll want to use open source software. So the difference between the two is kind of a question of where do you want to place your trust. In proprietary code, you place your trust in the corporation, right? That they have the financial incentives and the resources and the reliability to create a piece of software, to create a product that the users are going to pay for, right? They have the incentive because they're going to take in money. You also have to place your trust in the governing authorities of that corporation, because obviously the government's going to tell them what to do. The problem with that is that you get these competing interests. For example, planned obsolescence. Apple, for example, has had a number of court cases where it was demonstrated that they were purposefully putting planned obsolescence into their updates so that the phone, like old phones, that their battery would die faster, that they wouldn't function because they want people to buy new phones. And then the other thing is you get this competing government incentives where the government doesn't care about protecting the consumer or the corporation. They just care about doing their spying activities and their self-interest, collecting taxes. So proprietary code has a number of challenges that open code gives us a lot of opportunities to overcome. So when you're talking about open source code, we're more trusting a community of people, a community of developers and users, project leaders, and you're placing your trust that there's a sufficient level of motivation, participation, and expertise among that generalized community so that the project can maintain maturity relative to its complexity. The other idea is that because the code is open, so in proprietary code it's closed so that no one can actually see the source code. So obviously that means that there could be backdoors, there could be bugs that are unknown, but open source code is available for anyone to take a look at. And so because of this, the idea is that the more people that are looking at a piece of software, the less likely it is to contain backdoors and bugs and government spying kind of stuff, NSA. But there are definitely challenges with an open source model as well. Because it's open source and very few, like you typically don't receive any kind of profit like a corporation does, sometimes it can be hard to find dedicated expertise to keep the code maintained, to develop the products. And then the other issue you end up facing is the speed of white hats versus black hats. So a white hat is someone that does hacking, but they don't use it maliciously. They just do it to try and find bugs and then help the community. Black hats are the people that are trying to find bugs and then take advantage and steal your Bitcoin or what have you. So the problem with open source code is that since the code is open, both the malicious actors and the good guys are starting from the same point. So you know, the idea is that hopefully we can keep all bugs shallow and all attacks limited when we have open source code. Applications, so the internet is 100% open source. TCP/IP is an open source protocol. I'm sure you guys have heard of BitTorrent. BitTorrent, and if you haven't heard about it, we'll talk about it a little bit later. BitTorrent was one of like really popularized peer-to-peer open source applications in a lot of ways. But ultimately, open source, it really shines in networking applications because nobody wants to pay a corporation just to connect to another person. Also, if you have an old laptop that just doesn't seem to be working, a lot of times you can just put a Linux distribution designed for older laptops and it'll just jump right back to life. Proprietary does really good in these things, video editing, smartphones. Like all of our smartphones, like Android is technically open source, but all of the other stuff on top of that, like the Google Maps and all of their programs, all that's closed source proprietary. What's up, Danny?
I recently started using an open source Photoshop replacement called paint.net.
Yep, and Linux has one called GIMP that's really good. And it's, yeah, it has most of the functionality. So in general, open source is becoming better every day, where you can basically do almost anything that you can do on like Windows or Mac. You can do most of that on Linux. There's still a few things, like gaming is an example of something that's still, you know, Windows dominates that market. But yeah, it's good just to like get involved and experiment. And for most people, you can meet all your computing needs with Linux. So that's the idea. That's sort of the beginning, the idea of open source versus proprietary. So yes.
Is there a solution for messengers, like everybody's using, you know, Telegram or whatever?
Telegram is an open source piece of software as well.
Oh, it is?
Yeah. It's one of the good ones, I think. Signal's perhaps people that are really security focused like Signal. Wire, yeah. So let's talk a little bit about client-server versus peer-to-peer. So probably you guys have all heard the term peer-to-peer. In a peer-to-peer model, basically everyone connects to everyone else. And if you want to download something, you're going to get content from multiple people at the same time. In a client-server model, you have one centralized source that's serving everyone else information. And there's benefits and disadvantages to each side. Here's a cool little graphic about the difference between centralized, decentralized, and distributed. So understand that there's a whole spectrum there. It's not just like black or white. There's peer-to-peer, and then there's sort of shades of gray in between all the way to client-server. So in a client-server model, you have a dedicated server, and typically you have some kind of permission-based access, right? You've got to query the server, query the website. Can I access your website? All of the data structure and storage is centralized, which gives you the advantages that it's very scalable, it's easy to index and locate files. Changes can be made very quickly and concretely. And it's easy to track client activity. Now, the disadvantages on this is that it can be expensive to maintain a big server, right? If you're serving thousands of people, you've got to have like networking experts, you've got to invest in the equipment, you're going to have a lot of electricity costs. So it can be expensive to actually run a node there. And of course, you get this single point of failure, right? When Facebook goes down, no one's accessing their Facebook. Or when the bank system goes down, right, no one can access their banking information, which rarely happens, but hypothetically, right, there could be single points of failure. The other thing is that you get traffic congestion. There's other issues as well. So, and funny enough, being able to track your client's activity is both a feature and a bug at the same time because it's not censorship resistant. And that's why we have Bitcoin. Because it is censorship resistant, because that's one of the places that peer-to-peer networking really shines. So how many of you have heard of BitTorrent? Right on. Okay, so good. Everyone kind of has a good idea. So in a peer-to-peer system, it's node-based. You know, Bitcoin has these full nodes where the participants act as both clients and servers simultaneously. So I might download some information from you guys, and then I'll upload that information as well. The data storage is completely distributed, and the advantages of this are we can have an open source network with open participation. We can get higher bandwidth. We use BitTorrent. One of the reasons is because you can download lightning fast, 5 megabytes per second, which is really efficient. It's cheaper for individuals to participate in the network as opposed to the client-server model where you have to set up a whole server and everything. It's also robust. It's really hard to shut down. Like the government has tried to shut down BitTorrent for a long time, and they just can't do it because there's too many people acting as individual nodes. So it makes it quite robust, and primarily the censorship resistant is the primary aspect that we're looking at. The disadvantages are primarily indexing and locating files. Because think about when everyone's storing a version of a file, you have to say, well, which version is the correct one? And this is where Bitcoin solved the consensus problem, the ability to update the network simultaneously. It's actually a very difficult problem. And scaling that is also a very difficult problem. Scaling peer-to-peer networks is another one of the disadvantages. Databases tend to be very difficult to manage for this reason. If everyone's storing a file that I'm actively updating, it's hard to know like what's the correct version. Did I release a new version that only half the people have? So there's again, there's always trade-offs to the different models of operation. So BitTorrent, right? It's an open source peer-to-peer network. Let's see. Jurisdiction is, so BitTorrent is legal almost everywhere you go, but the question is what you download and what you upload. I would definitely recommend use a VPN to access BitTorrent if you're in a country or a jurisdiction that doesn't like it, like the United States, for example. You pretty much want to always use a VPN in the United States for downloading, for pirating files over the internet over BitTorrent. And we'll talk more about VPNs later and how to evaluate them. Okay, so let's talk a little bit about Linux. We've talked about open source, and Linux is sort of the quintessential open source application that everyone always talks about. So Linux is an operating system as an alternative to Windows and Mac. And when people say that they run Linux, what they really mean is they're running something called a kernel, which is a very low-level language that talks directly to the hardware. It runs right on top of the hardware. So there's the Linux kernel, and then there's like 1,000 different distributions of Linux. So it's open source, so people take that kernel and then they modify it and they add programs on top of it. So we have really cool operating systems. The primary ones people have heard about probably are Debian and Fedora.
It's not too long an explanation.
We're getting there, Chris.
How does kernel fit in with files?
So the first thing that happens, and we'll actually go over that in just a second. But yeah, the kernel is the first thing that gets loaded by your BIOS when you power on your computer.
Right, the next one.
Yeah, exactly. So you have the Linux kernel, and then you have a couple variants. You actually have hundreds of variants, but Debian and Fedora are very popular distributions. And then people have even taken those versions of Linux and added onto them. So you've probably heard of Ubuntu, and also Linux Mint. So this is sort of this is the more base fundamental layer. Here's an extra layer of abstraction, right? And then you have these other operating systems. And we'll talk more about these operating systems and which one you'd want to use and why. You guys have all heard of Edward Snowden, right? Hopefully. So Edward Snowden, Tails is an operating system that Edward Snowden used when he was trying to communicate with the media so that he didn't get caught by the NSA since they're surveilling everything. It's designed to run on a USB, and you plug it in to any random computer that you want, and it operates only on the RAM, on the surface level, and then it deletes all activity. And it also connects to Tor. Hopefully you guys know what Tor is, but if not, we'll talk about that too. And Wonix is also another distribution designed to help you access Tor. They're both very lightweight distributions. Fedora, there's a program called Cubes, and it's designed to run virtual machines, which we'll talk a little bit later. It's basically sandboxing different activities so that if something bad happens, it's only isolated to that virtual machine. And then there's a bunch of other different versions of Linux as well. Android, you'll see it down there as well. This is a chart of all the Linux distributions since 1992, 93 when it first got released. Here's that chart kind of blown up. So yeah, there's literally just 1,000 different distributions. But luckily, you don't need to know them all. The ones we're going to talk about are primarily the ones that you're going to want to play with. So Debian is designed to be very stable, very easy to use, and a very large repository of programs. Ubuntu and Linux Mint are sort of versions of Debian that have even more stuff thrown in there. And I always recommend, if you want to get into Linux, start with Linux Mint. This program, this version looks a lot like Windows 7. It comes prepackaged with all kinds of really cool tools, including a video editor, or I'm sorry, an image editor, all like an entire Office suite, you know, PowerPoint, like all of this that you're looking at I made on a Linux distribution. So Linux Mint is like definitely one of the best places to start. There's a lot of support on YouTube. It's really easy to figure out. You know, as long as you've got just a little bit of a technical mind, you don't even have to have that much. Like you just like to tinker. That's all you really need. Okay, so Wonix is a lightweight distribution. It's the default designed to access the Tor network, which is when you hear about people buying drugs on the dark web, that's Tor. And it's designed to run as a virtual machine, which we'll talk a little bit more about in a second. Yeah, and then Tails, like we talked about, Edward Snowden used the Tails system to stay hidden from the NSA. Because again, it's designed by default for security. You don't have to think about all the crazy configuration setup. They've taken care of all of it for you, so it's really easy to use. Let's see, Fedora is another version. It's more for like people who are that like to be on the cutting edge of new software releases. It's a little bit harder to use, not that much harder. They also have a whole bunch of programs as well. Yeah, and then there's Cubes, which I'm actually running on this laptop. It has Cubes, and we'll use a graphic later to describe how Cubes works. Okay, so there's a lot of support online for most of this stuff, especially for the Linux Mint and Ubuntu. If you want to try it out, what I recommend is actually putting a version on a USB and go to the store, like maybe Best Buy or Fry's or wherever you go, and just pop the USB and boot off of that and see how the computer works. Connect to the internet, play some videos, just make sure everything works fine, because some hardware doesn't always work great with Linux, especially very new hardware, like within the last 3 to 6 months. But old hardware usually tends to be pretty good. Typically, your Wi-Fi card, your audio card might have problems. Yeah, so I don't want to like just blow complete smoke up your ass and tell you that Linux is perfect and it's, you know, it'll always work in every situation. Sometimes it won't. Okay, so since we're talking about software, it really behooves us to understand the hardware aspects of it, because software only runs on top of hardware. So we won't get too crazy deep into this. But probably most of you know these terms, but we'll go over them real quick. So a central processing unit is the actual logic device which executes instructions and code. It actually does the calculations and computations. And your CPU needs a place to dump memory, to dump files really quickly and access them. It's called your random access memory. And then you have a hard drive that's a little bit harder to access. It's slower. So what happens, your CPU will pull all that information off the hard drive and dump it into RAM temporarily, so that it can access the files quickly. You've got a user interface and all these other things. The main one I want to focus on here is the motherboard. A motherboard is essentially a component that ties all of these other things, all of these things up here. It ties them all together. And the motherboard has its own embedded software. It's called firmware. It's really hard to change. And again, it's proprietary for the most part. And there are a few open source solutions, LibreBoot, CoreBoot, and Linux Boot. So all of this stuff here, this is maybe a better way to represent it. So you've got all your different units, all your different components here. So let's suppose that this is your laptop and you turn it on from a completely powered down state. So the first thing that will happen is your computer, the controller for this whole motherboard is gonna jump to life, and the embedded software, typically called the BIOS, people just generally call it BIOS, but there's a few other terms for it. So what's gonna happen, it's gonna load that firmware into your central processing unit. So now your CPU has instructions that it can actually execute. And the first thing the CPU is going to do is look for if you have a hard drive. This is a common naming convention, dev SDA. Don't worry too much about the convention. So the CPU is going to look, the BIOS is going to look in there and say, oh, look, there's a Linux kernel on here. So it's going to load the Linux kernel into the CPU, and it's going to hand over control to that kernel entirely, and then the firmware is going to basically go back to sleep. So now you have the very base level of your operating system running now. And the kernel is, again, so you've got your hardware and you've got your firmware. The kernel is like one of the lower layers of abstraction before you run all of your extra programs, like accessing the internet and video editing and whatnot. So it'll continue to load your entire operating system. Oops. It'll continue to load your entire operating system until everything is booted up and ready to go. Here's another way of kind of visualizing this. On the lowest level, you have your hardware. There's firmware which runs. It's embedded into your hardware. It's kind of like code. And then the kernel is loaded on top of that. Finally, your operating system and the programs are the highest layers of abstraction that you're running on your hardware ultimately. Okay, so virtual machines. It's a really cool concept where your operating system actually runs an entirely other operating system inside of it. So I might be running Linux, but if I wanted to, I could actually install Windows and simulate running an entire computer within inside Linux. And you might ask, well, why would you want to do that? So I run Linux, and maybe there's like one program that I can only get for Windows. So that's one reason I would want to do a virtual machine, a Windows virtual machine, is so that I can run programs that I can't run on my normal operating system. The other really important aspect of this is you can segregate dangerous activity. So let's see, I think the next slide, yeah, here we go. So here's our hardware, here's our laptop, and I'm running Qubes OS on this system, right? So this is my base level operating system. But maybe I want to create a little virtual machine, just like just a little small machine, and I might use that machine to access only trusted websites. I might use another virtual machine for untrusted browsing. And the reason that I would do that is, let's suppose I get into some, I don't know, I download some malware, something bad happens in this untrusted browsing machine. Because it's sandboxed into its own little virtual machine, it won't affect the outside system. Because as far as the virus is concerned, or as far as malware is concerned, it's already infected the host machine, right? Because the malware can only see that one little operating system. So Qubes is designed to have multiple virtual machines to run all of your processes. So there's Microsoft Windows. I might run that. Another cool idea is you create a disposable virtual machine. It's like a one-time creation. So it's kind of like if I were to run Linux inside of Linux, right inside of Linux. If I download some malware, I can just delete that virtual machine, and then the rest of my host system, the Qubes system, is still good. And so we use this for networking. A lot of people use this to connect to Tor. Wannix uses a series of virtual machines in order to get you connected to Tor and to funnel all of your traffic to the dark web when that's what you're trying to access. Another networking machine. Okay, privacy, anonymity, security. These are terms we hear a lot, and this is a quote from the Constitution. The right of people to be secure in their papers. And really what that's saying is the right of people to be secure in their information. So everyone probably has a little bit different definition of privacy and anonymity. The way I like to look at it is that privacy is the ability to hide from view your information and the ability to control its dissemination when you want to. I look at anonymity as being the ability to obfuscate or segregate your identity in different cases. So I might segregate my real life identity from when I'm trolling people on Reddit. And that's, so if you haven't heard the term doxing, doxing is when you're basically de-anonymized. Someone finds your real life identity and ties that to maybe some account where you were trolling or shitposting or whatever. So to me, security is the extent to which you can accomplish both privacy and anonymity when you want to, when you desire. So these things are related. So an interesting thought that I had was that you want to keep your information private sometimes without being anonymous. Maybe you have medical files, and you know I have medical files, but you don't know what's in there. Interestingly enough, sometimes we want to speak anonymously because we have private thoughts that we want to share. So interestingly enough, sometimes higher levels of anonymity gives us the ability to be less private in cases that we want to. Let's see, why it's important. I think we all know why it's important, privacy and anonymity, right? It protects our freedom of expression, association, and really, if you've read 1984 or Brave New World, it's really freedom of thought, because when you can control language and you can control people from speaking their mind, then you can kind of control their thought. Perfect, great quote from Edward Snowden. Arguing that you don't care about privacy because you have nothing to hide is no different than arguing that you don't care about free speech because you have nothing to say. Thanks, Edward Snowden. Okay, we're going to get in the weeds a little bit here. We're going to talk about encryption, what hashing is, what digital signatures. Some of this is going to be a little bit complex. Don't worry, there won't be a test or anything. Don't worry, like I wouldn't expect anyone to be able to assimilate all the information, you know, at once. But it's just a cool like background stuff. Like, how does this stuff work? Okay, so fundamentally, encryption is speech. The guys that created one of the early versions of encryption that we use, called GNU-PG, it's very commonly used. They were actually prosecuted by the federal government of the United States for digital armaments, right? They were accused of exporting digital armaments. And so they had to go through this whole process where they actually printed out their entire encryption program onto like physical, like a book, like a huge book. And then they mailed it across an international border, which is fundamentally protected like for hundreds of years now. And then once they received it internationally, they actually scanned the entire thing back in. And at that point, the government was like, well, shit, that's like totally protected speech. So they basically dropped all their cases. So yeah, that's an important bit of philosophy, perhaps. Okay, some of this will be complex. Frame of reference. Oh yeah, software does all the hard stuff for us now. So you don't really have to like know how to do all these things. I don't know the math. It's like your car, right? You don't have to know how an internal combustion engine works to drive your car. And this shit's hard. Like, software and security are really hard. So you want to do your best to educate yourself, to understand your attack surfaces, to know what you're trying to defend against, and then assess, you know, the risks versus the cost, all that good stuff. And security is never perfect. It's always some kind of shade of gray. Okay, encryption. So I think we all know that encryption is sort of a clever scrambling of the data to lock it so that it looks random, right? So that anyone else that doesn't have the secret key. So let's just do like a little example of how we could encrypt something. No one's going to use this algorithm that I'm going to propose right now. Okay, so we're going to encrypt hello world with just an algorithm we're going to make up right now. So let's just convert each of these letters to a 2-digit numerical value, and we're going to multiply that number by some other number that we're going to make up. So here's our data. H is the 8th letter in the alphabet, E is the 5th, so on and so forth. So now we have this big-ass number. We're going to make our key the worst possible password ever. Our password's going to be password. So P is the 16th letter, A is the 1st, so on and so forth. And per the algorithm that we just made up right now, we're going to multiply those two numbers together, and boom, now we have some kind of encrypted data. This is a really bad algorithm. No one would ever use it, but it's just a cool example of how you could encrypt something. And it's actually not too far off. The encryption we use now is based on prime numbers, like very large prime numbers, and a cool mathematical function where you take the remainder. So you're dividing prime numbers, right, which you don't have any divisors, so you take the remainder, but we won't talk too much about that. So this is called symmetric encryption because our key goes both ways. We can lock and unlock the data with the exact same key. Symmetric encryption tends to be faster than other forms of encryption. Here's another way we could do it. So let's suppose we have our data, we put it into a matrix. We can start swapping the rows, right, and now we have a result. We can swap the columns, and we can keep doing this a number of times until our data is like totally scrambled. But because we have the key, so the key will tell us how did we swap which rows and which columns and how many times. So we can always recover the information, right? That's important with encryption, is we're trying to make sure we can recover the information. This is in contrast to something called hashing. I'm sure you guys have heard, you know, the Bitcoin network is running hashes all the time. So a hash is actually designed so that you can't recover the information. It's designed to be able to give you a fingerprint of a very large set of data. So can you guys see that? Hopefully that's big enough. Cool. So encryption preserves data, but hashing is designed to completely scramble it so that it's totally unrecoverable. And the other thing is you want to be able to take any size of data. It could be a gigabyte, it could be a terabyte, and it's going to perform sort of a standardized mixing and resizing operation repeatedly until that data comes from whatever its original size, doesn't matter, into a standard set of digits, of bits. So have you guys heard of SHA-256? Nope, okay. So SHA-256, right, is the classic Bitcoin hashing algorithm. It's called SHA-256 because it's a secure hashing algorithm, and your end result is 256 bits long. So if we were to take the SHA of password, right, you just dump this into the algorithm, this is the result you're actually going to get. This is the actual output of ones and zeros. So that's 256 ones and zeros. We could represent that number in what's called base 10 or decimal, which is our familiar counting system, 0 to 9. In Bitcoin and in computer science, we use different versions. You don't have to just use 10 digits. You could use 16. We could use all the letters of the alphabet if we wanted to. So basically, one digit would have the ability to represent 64 different numbers because that's how many alphanumeric characters we have. And notice each time that we add more, we go up in number, right? It actually gets shorter. So Bitcoin uses base 58, which is slightly different than base 64. It throws out things like 0, which is it throws out capital O, which is too close to 0, and lowercase l, which looks too much like a 1. This is my Bitcoin address. It's a Bec32 SegWit address. Send me Bitcoin. Okay, so just to recap on hashing, it's a one-way operation. You can't recover the original data. It creates a specific fingerprint of whatever thing that you have. Even just one tiny bit of difference in your original data will make a wildly different result. Like, for example, here's password. That's the hash of password. But if we just change that one letter to an O, we get a totally different result. Looks totally random. So why do we care? Because when we download a big file, like a 1 GB operating system, maybe Linux Mint, we want to be able to verify that that file is perfect integrity. Every single digit is exactly what it should be. And because if you change a digit even slightly in a hash, you're going to get a wildly different result, then we can use that as a fingerprint for that file, and we can make sure that it's actually the exact same file. Okay, so asymmetric encryption, and if I'm talking a little bit fast, I apologize. I just don't want to bog down too much and get here in the weeds stuck too long. Okay, so asymmetric encryption is different than symmetric in that you actually need the same key that encrypts the information is not the same key which decrypts the information. This is very useful when Alice wants to talk to Bob. But they're not together. They're not geographically located in the same spot, so they can't share a symmetric key. So they've got to come up with a little bit smarter, a little bit more tricky algorithm. So how can Alice encrypt a message so that only Bob can unlock it? And then how can Bob be sure that it was in fact Alice that sent it? And furthermore, how can they do this when they're not even in the same location? They've got to send information over the internet, right? They can't send a symmetric key over the internet because whoever's watching will be like, hey, I know your key. Let's see. So to do this, I'm sure you guys have all heard of a private key and a public key. This is what asymmetric encryption is all about. And one of the first things to know is that your private key, you can use that to derive your public key from something like a hash, something really similar to a hash. But you can't go the other direction. So it's a one-way function again. Your private key, with some math magic, can get your public key, but you can't go the other direction. Obviously, this is important because your public key is for public distribution, and you don't want people to figure out your private key from that. So there's sort of the two things that we're trying to accomplish. One, we want to lock the message so that only the intended recipient can unlock it. And on the other hand, we want to prove who actually sent the message. So they're two separate problems, and we'll look at them individually. So here's our key pair, public key, private key. Let's suppose that I want to send, let's suppose that you want to send me a message so that only I can unlock it. So what I'll do is generate a key pair. I'll keep my private key to myself, and I'll send my public key far and wide. I'll distribute it to Reddit and I don't know, Stack Exchange. I'll put it on GitHub, wherever I can think to distribute it, so that everyone can be confident, right, that it's actually my public key. So what you'll do is you'll use my public key, and you'll combine it with the message, so that once you encrypt it, there's this level of ciphertext. And again, keep in mind, it's asymmetric because it's a one-way function. You can't go backwards. So if you see my ciphertext and you have my public key, you won't be able to actually derive the message. All you can use is my public key to encrypt it. So my private key is the only thing that can actually decrypt that text, and boom, I get my message. So now I'm like, now you've confidently sent me a message that you know only I'm able to decrypt, only I'm able to see it. On the other end of that spectrum is that maybe I want to send you a message, or maybe I put out some software and you want to be able to validate that it was me that sent it and not some like hacker in the middle. So again, we've got the private key, public key. What I'll do is I'll take my message and I'll encrypt it with my private key. And then interestingly enough, the public key can decrypt things that I encrypted with my private key. So in that way, if it successfully decrypts to a text-readable message, like an actual message, if the public key successfully decrypts this ciphertext, then you know that whoever held this private key is the one who encrypted it, which hopefully should be me as long as I didn't compromise my keys. Okay, the problem with asymmetric encryption is that it's slow. It takes a long time. We would never actually be able to encrypt a huge file and send that over the internet. It would just take too long. So we have to do a little bit more cool, tricky math, which isn't really that too hard. So let's take our classic Alice and Bob, and they're both generate a key pair. And now, of course, they're going to exchange their keys, right? So now Alice has Bob's public key and vice versa. So there's this really cool property that in the math of all this that works out so that if Alice takes her private key and sort of mixes it with Bob's public key, she ends up creating this this long number. Like when we say a private key or public key, we're just talking about a really long number, right? Like your Bitcoin private key is just a really long number. So by mixing her private key with Bob's public, she creates this number, this shared secret. And interestingly enough, Bob can do the same thing with his with his own thing. It's kind of like a commutative property of math when it's like maybe like A times B times C. You can change the brackets kind of deal. It's similar to that. So now Alice can take the message. She can use a symmetric key, which remember is a lot faster than asymmetric encryption. She can send this message, and then since they share this secret that they've exchanged only by exchanging their public keys, but only the two of them know that secret. This is how Telegram works and Wire as well. Digital signatures. So we're getting close to the end of the encryption part, I promise. So digital signatures need both asymmetric encryption and hashing. You care about digital signatures because if you're, suppose, maybe the Bitcoin network, a miner, or a node, you need to see valid digital signatures to say, yes, that was a valid transaction. The owner of that private key, like they can verify, right, that was the owner, so that they can process that transaction or process that movement of Bitcoin. Let's see, we'll skip all that. So real quick, let's suppose here's Alice, and let's suppose that we are the end users, and we want to download some operating system. So this is the internet right here. Maybe that's github.com. And here's another level of public distribution. So Alice has this file right here. Let's suppose it's Linux Mint. It's a 1 GB file. She's going to send that to the internet, and maybe we'll download it off of GitHub. So now we have the file that we think is from Alice. We hope it's from Alice, but we're not quite sure. So Alice is going to have her key pair. And the first thing she's going to do is distribute her public key far and wide, right? There's these key servers which are designed specifically to store public keys. There's also, like, she might give it to her friends. She's going to post it on public forums, like I said, Stack Exchange, Reddit. So what we're going to do is acquire Alice's public key from as many different places as we can, especially if it's something as crucial for us as an operating system that we're worried that maybe some man in the middle or woman in the middle, I don't want to be sexist, might have gotten in there and given us some malicious file. So we're going to use maybe the cellular network to check some key servers. Maybe I'll ask my friends. Maybe I have a mutual friend with Alice, and they can say, yeah, that's definitely her public key. So once we're confident that this is actually her public key, there's one more piece that we need, and that's the digital signature. The way this is done is Alice takes her file, her big operating system file, the 1 GB. She's going to hash that with SHA-256, and that's going to produce, our standard, looks like a Bitcoin address, just like a relatively short number. She's going to encrypt that number with her private key, and that's going to be the signature, right? So the signature is the hash, the encrypted hash of whatever file she actually wants to send. She's going to distribute the signature, which we'll also download, and then we're going to do the process in reverse. We're going to use her public key, hopefully, to decrypt this file right here. Because remember, the signature is an encrypted file, and it can only be decrypted by her public key. So if we use Alice's public key and we successfully decrypt that signature, we say, okay, that signature came from Alice. It definitely came from Alice, or at least someone controlling that private key. And we're going to take a look at this number that is inside the file, and this is the hash of the file. The other thing, the final piece we're going to do is take the file that we downloaded, and we're going to hash that ourselves. And we're going to say, do these two numbers match? If they do match, then we know for sure that whoever is controlling that private key definitely also created that software, definitely is the one that distributed that software. So that's the most complex we're going to get today. My eyes would be glazing over too. So encryption recap, symmetric. You need the same key to go back and forth. It both encrypts and decrypts. It's fast. Hashing is a standardized one-way mixing function that doesn't require a key. And a single wrong digit creates a wildly different output. We use it to fingerprint files. And then finally, asymmetric encryption is the basis of private and public key pairs that we can use for secure communications when we're geographically separated. And then finally, a digital signature is just a way of verifying a file that someone has distributed, so we can know that we can trust the file. Like, so when you download the Bitcoin Core client, you want to be able to verify that that actually is the real Bitcoin Core. And so digital signatures is one of the ways we do that. Okay, but GNU-PG, so there's software programs that do all this hard work. Hopefully, this has been slightly helpful for you. Okay, so we're done with all the crazy encryption math stuff. The rest of this will be a lot easier. Okay, so a VPN is a virtual private network, and I definitely recommend that everyone has a VPN that uses a VPN. So it's good for certain things and not for others, and there's often some misconception here about what it's good for. So a VPN, the idea is that you're going to encrypt your traffic and you're going to funnel it through some kind of provider so that that people that might be listening can't see your traffic and they can't figure out where your location is. So graphically displayed, here's Bob, and he's in Starbucks. Here's the Wi-Fi. There's probably some other people here. Maybe one of these guys is malicious and he's like sniffing packets. He's like trying to listen to everyone's internet traffic. And Bob wants to access some website out here, but he doesn't want all these fuckers to know, what he's doing. So what he'll do is he'll put the so you've got the destination IP of this address, right, of this website. And so everyone here that might be sniffing, including Starbucks, the ISP, and the whole World Wide Web, can see where Bob's traffic is going. So what he decides to do is put a VPN in the middle of this process. Other people will connect to the same VPN for sure. And the whole point of this is to encrypt the IP address. His final IP address is going to be encrypted so that no one can see it. And instead, he puts the VPN IP address. So now all of these people, they can't see his final destination. All they see is that he's talking to a VPN. And the VPN acts as sort of a middleman so that you can help to hide your IP address, your geographic location. Let's see. Okay, so VPNs are good for certain things. It can prevent public Wi-Fi, right? It can protect you at public Wi-Fi. It can reduce your traffic visibility from your internet service provider. It doesn't entirely, like if they really want to figure it out, they'll probably be able to, especially with law enforcement. You can use a VPN to get around firewalls or like, for example, morph token is kind of like another shapeshift that, shapeshifts had to do KYC, so now you have to like sign up with an account and prove your identity to shapeshift. Morph token is a website you can go and kind of do shapeshift-like stuff without providing your identity. But morph token is blocked in the United States, so if you want to access morph token, use a VPN. So what will happen is your VPN might be in a whole other country, and so as far as morph token is concerned, you're accessing from the site of the VPN server, not the site you're actually accessing. Yeah, you can use a VPN to sort of get outside of a firewall and censorship. Okay, here's the maybe. You can maybe obscure your location from the websites you visit, or you can obscure your identity, maybe. You might be able to hide your ISP that you're using Tor, which again, we'll talk about Tor in a minute. And you might be able to obscure your geographic location from Tor itself. Here's the bad. VPNs don't prevent browser fingerprinting. And we'll talk a little bit about browser fingerprinting. It's essentially ways that websites use your cookies and they use information that you broadcast to them to identify who you are. We'll talk about that more in a second. Okay, VPNs are, sure, go ahead. Because if you're a government and you have access to large network resources and you're surveilling a lot of different points, you can de-anonymize someone. Or if you're a large corporation, you have large corporate resources. Let's suppose that I'm Comcast and I also own a VPN provider. Well, obviously I'm the VPN, so I can tell who's going where. And there's other like tricky little things that they do with your web browser that identifies you in ways you wouldn't expect. Okay, so finally the last so the bad, it doesn't stop the browser fingerprinting. It's weak protection against large dedicated actors, the FBI, the alphabet soup people, and also any corporations with just really big resources. The other, and perhaps the worst aspect, this again is a corporate client-server trust model. You have to trust your VPN, and they're a corporation, right? They're gonna comply with government orders, even gag orders, right? The government's gonna come say, hey, this IP address, we're gonna surveil them and you're not allowed to tell them, right? A lot of, I would say most VPNs are honeypots. They're just selling your data to advertisers, to government, to the highest bidder. So VPNs, I definitely recommend using one, but understand that it has limitations. It's not a perfect solution. So how do you select a VPN? If you tried to get on Google right now and say, hey, what's the best VPN? All you're going to get is affiliate marketing and a whole bunch of bullshit. You're going to have a really hard time actually finding reliable information on these VPNs. There are some good websites out there which I've sort of dug up, and I have a whole bunch of resources which we'll send out an email for everyone after this is done, so that you can, if you really want to learn more and really get in the weeds on all this stuff, I'd definitely recommend it. Yeah, I would not trust a free VPN. Remember, when a service is free or when a product is free, you're the product, right? Generally speaking. Okay, so here's some things when you're trying to select a VPN and you want to know which one to select. Here's some criteria to look at. First of all, are they running third-party tracking scripts? And there's little add-ons for your internet browser that you can see what websites you visit, what they're trying to run. And you would be amazed at how you visit a particular website, and then there's like 10 other websites that it's actually accessing third-party websites and running all that content in your browser. Like, for example, Google trackers, and some of it's not nefarious at all, but some of it's like totally tracking you. Okay, hyperbolic claims. If you get on a VPN website and they're like, you'll get perfect protection, 100% anonymity, those are just stupid hyperbolic claims. And what they're telling you amounts to a lie from the very get-go, right? They're running third-party scripts that they're not telling you about in your browser. They're telling you hyperbolic claims that just aren't true, and they know they're not true. So, you know, those are kind of like little things to look for.
Or also anybody who says military-grade encryption. That's such a bullshit phrase that's completely meaningless.
Yeah.
If you read that somewhere, it's from hundreds.
Well, interestingly, the military created a lot of the encryption, right?
Yeah, sure, but it's
Like they're technically true, but it's just a catch. Yeah, it's a hype.
Like everything is military-grade encryption.
Yeah.
So, you know, like when, where, in what decade, what country.
Okay, jurisdiction's another aspect. You know, I wouldn't use any VPN that originates from the United States as a corporation. There's also this thing called the 5 Eyes and the 14 Eyes. So, like, per the Constitution or whatever, the United States is not supposed to spy on its own citizens, but the UK can spy on US citizens, no problem. And the United States is okay to spy on UK. So what they do is they spy on each other, and then they share their information. So they make these little, you know, pacts. And then there's enemies of the internet. Reporters Without Borders has good data on that. Like China is an enemy of the internet. Russia, which they're going to shut down the internet for like a day or an hour. Anyways, yet I digress. Okay, information collection. You want to see what kind of information do they log? Do they log your IP address? Did they throttle? Let's see. Oh, finally we get to the services, because we have to worry about all the spying shit first. But so services, right? How many servers do they have in which different countries? I personally like to connect to Romania and Iceland because those have really good not privacy, but really good internet laws in terms of freedom, what you can download. Like Iceland doesn't give, they don't care about BitTorrent. They don't prosecute anyone. So they're really good jurisdictions to go through when you're trying to connect to a VPN. Let's see. Oh yeah. Make sure that they don't throttle or block Tor. Some VPNs will block Tor entirely because they just don't like it, or they'll block BitTorrent. You're like, I got my VPN, I'm going to download some movies, whatever, and then you find out that your VPN actually blocks BitTorrent. So just do your research ahead of time. Like I said, I'll give you some good websites. If you sign up for a VPN, at a minimum, it should not require your personal information or like a credit card. You should always be able to pay with some anonymous form, which is basically crypto. A lot of them you can, before like crypto got big, you could use a VPN and just mail in cash. The best ones that I like, Molvad, I think actually, yeah, here we go. Molvad and iVPN. So as far as I can tell, Molvad is one of the only VPNs that you don't have to provide an email address. I'm sure there's others, but yeah, I don't even want to give them an email address. And Molvad is super cool. You get on there, they generate you an account number, which is really long, kind of like not a Bitcoin address, but a really long number. And that's all you need. You don't even have a username. And then you pay them with crypto. Hopefully, you know, you're on the dark web paying with crypto. No, I'm just kidding. We'll get to that. Okay, Molvad, yeah, M-U-L-L-V-A-D. Yeah, when you get on Google, you're going to see just dozens and dozens of independent reviews for VPNs, but they're all affiliates. They're all paid. I mean, you can hardly get on Google and do any kind of search nowadays without just finding a whole bunch of affiliate marketing bullshit. I can't even use Google to find stuff now, maybe a little bit. Okay, so at long last, we come to Tor. People call it the deep web, they call it the dark web. These terms are kind of fast and loose. The proper term for us to use is Tor, and it means the onion router. I'll say like, oh yeah, on the dark web or the deep web, just because people like, they understand what that means. So, you know, but you say, yeah, do you use Tor? And they're like, no, I don't know what the fuck you're talking about. So Tor is very similar to a VPN, but it just takes it to the next level. You have, instead of one point of, one point which sort of obfuscates your information, you have multiple hops between different locations to like totally obfuscate things. It's also an open source protocol, whereas your VPN, right, you have a corporation, they've got a server, right, they're doing whatever they want behind closed walls, but Tor, again, is an open source application, so the code is reviewable. It was actually created by the NSA, funny enough, but it would make sense. The deep state, the CIA, NSA, they have a big need for being able to communicate securely. There's always the raging debate about Tor and whether or not it's compromised. But it's better than not using it. Like if you're really like doing shit that might get you in trouble with the government, it's better than not using anything at all, and it's much better than a VPN for sure. Let's see. Okay, Yep, there's the basics. Okay, so here's the idea. You've got Bob, and you've got some website he wants to visit, and he knows he's got to go over the ClearNet, right, the visible internet. So what Tor is composed of is a 3-hop relay. You have an entrance node, you have a relay node, and then you have an exit node. And so Bob is going to choose at random a place to enter the Tor network. So this whole thing right here would be considered Tor, the Tor network. So Bob is going to select an entrance node at random. There's about 2,500 of them. And then that entrance node is going to forward to another relay. Again, Bob is going to select which relay. And then that's going to also be randomly connected to, finally, an exit node. And then the exit node will forward Bob's traffic all the way to his destination address. And in this way, the website that he's visiting is masked, or the website he's visiting only sees that he's coming from a Tor exit node. They can't see that Bob is, you know, in Acapulco, Mexico, or in Starbucks or whatever. So this is a much better way of obfuscating your geographic location and your identity as well. Again, it's not perfect. People think they can just hop on Tor and do whatever they want, and then they compromise themselves in other ways. So let's talk a little bit more about how this works. So if I'm Bob and I want to send a packet of information over the internet, here's how I'm going to put this together. The first thing I'll do is I'll have my data for the website. I'm going to have the IP address on that website, right? I have to include that. How the hell else is it going to get there? But I'm going to wrap that website information in a layer of encryption, right? And I'm going to send that to the Tor exit IP address. But before I get there, someone is going to have to take a look at it, the middle node, and they're going to have an IP address. And each of these is progressive layers of encryption. This is why it's called the onion router, because ultimately it looks like an onion. Every new participant or every new step in the process of forwarding your data unwraps a new layer of that onion. And it's a really good way of obfuscating who you are and where you are. Okay, so finally, the last layer of encryption is this entrance node. What Bob is going to do is take this big packet. Think of all this as just a really big packet of information. And the only thing that anyone can make heads or tails of on it is that it's going to a Tor entry node, an IP address associated with a Tor entry node. So Bob's going to take this big chunk of data, right? The first thing that's going to happen is all his ISP is going to see, right, Starbucks, is that it's going to a Tor entry node. The entry node is going to unwrap the first layer of encryption, and they're going to say, oh, okay, this is going to this particular Tor node in the middle. The middle node is going to unwrap the next layer of encryption, and they're going to say, okay, here's the exit node. The exit node is going to unwrap yet another layer of encryption, and the exit node finally now is going to see the IP address. So in this way, this person, and none of these guys actually know where Bob's traffic is going. So finally, the website gets the data. Okay. Oh, here we go. The good, the bad, the ugly. So the good, it's really good. The Tor. Using Tor is great at hiding your IP address from the websites you visit, unless you de-anonymize yourself. We'll talk about how you can do that. It's also a great way to obfuscate your web traffic from your internet service provider and from hackers. It's good at preventing dragnet surveillance by large state actors. So dragnet surveillance is when they're just like, okay, here's a communication fiber optic. Let's just collect everything and dump it onto some server, just dump it onto some storage device, right? They're collecting dragnet information. So it's really good at preventing dragnet information surveillance by the state, which is, everything without prejudice, I guess. And there's not that many active vectors of shutting down Tor or of attacking Tor. In other words, actively de-anonymizing you and messing with your privacy. But the bad is that it's slow. Government definitely runs malicious entrance and exit nodes. They really have an interest in figuring out who's on Tor because, Silk Road, Ross Ulbricht kind of stuff, right? The one thing that they're really good at, or that can be done, is something called timing correlation. It's basically, I'm going to send a packet over the internet, and some router in the middle, maybe the Tor entrance node, is going to introduce a really slight delay from every packet, right? Because you're sending thousands of packets per second. So they're going to introduce a really predictable slight delay between all the packets, and they're going to wait and then listen on the exit node and see where that same delay occurs. And in this way, they can actually de-anonymize you. The thing is, unless they're targeting you, unless they're trying to look at you specifically, you're going to be pretty anonymous on Tor. So if the government wants to target you, Tor, yeah, it's better than not using Tor, but if the government really wants to target you, especially the NSA, there's not much you can do to stop them unless you're just really next level Edward Snowden kind of guy. But the good news is that Tor will prevent the government from just mass surveillance on your activities. And the more people that use it, the more people that participate, the more anonymous we all become. The harder it is for them to make heads or tails of all the data going across the network. Let's see. Oh, here's another bad. Your internet service provider is going to know that you're using Tor, right? Because they're seeing that you're going to a Tor entrance node. So your ISP is going to know. And some people say that just using Tor sort of paints a target on your back because the government's like, oh, this motherfucker's using Tor now. Probably he's doing some bad stuff. We should surveil him. But they don't have nearly as many resources to track individuals as you would think.
And also, if everybody uses Tor, then we're more anonymous.
Yes. Yeah. The more people that use this this protocol, it sort of protects everyone. It's like herd immunity, kind of.
Just use or run a node?
The more people that run nodes, the better. Even better. Yeah. Run a node. Run an entrance exit node. Yeah. All of the above. Okay. So some websites block Tor. Like I challenge you to get on Google and actually load any Google website from Tor. They won't let you. They give you all these reCAPTCHAs. You know, click, 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 click. Tell me how many buses are in this picture or whatever. So some websites will block Tor. Just know that that's the case. And there's kind of a little bit of a learning curve with all this stuff, of course. But you definitely want to do a little bit of research before you just hop on there and you know, buy a fake passport and guns. Okay, so we talked about how can you de-anonymize yourself accidentally. Browser security weaknesses are the primary method they do this with. So your browser stores cookies and fonts. Some people run different plugins. They know what your time zone is. In order for a website to run well on your computer and look nice and all the active content, you know, like Facebook and pictures, they have to know what your screen resolution is, what kind of system you're running, what web browser you're running, what version it is. And so every single one of these little things is extra data that they can use to de-anonymize you. So for example, pretend that I'm accessing a website and I give them my screen resolution, 1900 by 700. They say, oh, okay, out of the 10 million viewers of this website, 1 million have the same screen resolution, right? So okay, that's still only 1 million, not much. And then they say, okay, well this guy's running Linux, and only maybe 100,000 of them that access the website is running Linux, and he's running these particular fonts and these particular plugins. So now, like every new bit of data sort of like narrows you down. And then finally, you come to like hardware fingerprints. So they're little fingerprints that happen at a hardware level that like are unique to each computer. And so they run these scripts in your browser. So for example, it's called canvas fingerprinting. There's a white box, and the website that you might visit says, hey, draw some pixels into this box, shade them these colors, and then tell me what that looks like. How did it look on your screen, like when you actually drew it there? And that's actually represented by a unique fingerprint, and then you'll send that back to the website. You can like choose in your browser to not do that, but that's such a unique way of identifying people. So when you go to Amazon, for example, and you buy a t-shirt, and then you go on Facebook, and you're like, wait, now I'm seeing all these advertisements for the same t-shirt I just bought on Amazon. That's one of the ways that they track you. So even if you're using a VPN, because you've given them all of these little bits of data that they can now use to identify uniquely who you are, actually 94% of the time, like literally almost everyone that's browsing the internet has a unique fingerprint based on all of these criteria that you're seeing up here. You might have heard of scripts, JavaScript. So for your HTML content to work well, when you access websites, they run all these different scripts to do all the cool stuff that we like with our active content. But unfortunately, those scripts are also tracking you across websites so that they can advertise and all kinds of stuff. Funny enough, reCAPTCHA is actually a tracking program. So they say, allegedly, it's to figure out if you're a robot, right, and maybe a hacker, some computer algorithm trying to hack a website. And sure, that's part of what they're trying to do, but the other part is, when you move your mouse, you personally have a unique way that you move the mouse. And because of your hardware is unique, it also moves the mouse in a unique way. So what they're doing is collecting data on that. So anyways, the other thing that can happen that's like, and probably you guys have noticed, so when you're typing stuff into Facebook, right, they have an area for typing text. One thing I've noticed is sometimes there's a lag on Facebook. When I'm typing text, there's like the letters won't appear right on time, and that never happens. The reason that happens is because Facebook's little messaging box that you're typing in is actually recording all of your keystrokes, and it's looking at the timing between your keystrokes, the common errors that you make, like which words you misspell. They're looking at all those things, and they can actually put a certain level of, they can fingerprint you to a certain level, maybe not like 100%, but you'd be surprised how well they can fingerprint a person just based on the way that you type, not even the content. And so they're storing all that data, and they're trying to figure out, okay, how can we, track people as they browse across the internet? And they got their VPN, and they thought they were anonymous, or they're on the tour, right? They're on tour, and they think they're anonymous, and now they're visiting some website, and they're typing again. But they're like, hey, we know that typing fingerprint. That looks just like this guy over here who we know, and boom, you've de-anonymized yourself even though you're on tour. So there's all these little gotchas, and I would just recommend, like, I couldn't possibly cover all of them here, and I don't even know half of them, right? But the more that you understand, the more that you sort of do the research before you start getting on the dark web, the more likely you are to avoid de-anonymizing yourself. And again, consider your risk, right? Are you in a country that's very repressive, and you're trying to do free speech, and the consequences for getting de-anonymized are severe, right? Myself, like, I don't really do anything that nefarious on the internet at all. So, but I still use Tor because I'm like, fuck the government. Like, why should they get my data for free? Why should my ISP get that data? So, if I de-anonymize myself, like, okay, it's not good. But I also use Tor for crypto transactions, right? We'll talk a little bit about crypto, and it's anonymous but not really anonymous, and you have to take certain steps. Okay, and here's a good point. Open source isn't like a magic fix for everything. Like Firefox is an open source program, but by default, Firefox runs almost all these scripts we talked about in the fingerprinting. Mozilla, who is like the parent of Firefox, has Google partnerships. So just know that just because don't be like, oh, it's open source, I'm good to go. Like, always do a little bit extra research and digging. Okay, browser security. You can adjust browser settings. Again, we won't go over them here, but I've got resources if you want to check them out. You can go into the about:config and change things. There's some cool plugins. I like uMatrix. It basically, when you get to a website, it shows you all of the things that the website's trying to load and run on your computer. And you can use it to disable all that stuff. You can say, no, 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 you can only load text content, maybe photos. You can spoof the type of browser that you're running. You can, like, I'm running Linux, in Firefox, but I can pretend that I'm running a Mac on Safari. Okay, and if you do use Tor browser, don't change anything. It's designed, so Tor browser has taken Firefox and it's hardened everything by default. So it's pre-configured to make everyone look exactly the same, and you want to maintain your anonymity by looking the same as everyone else. And that's where more people using it protects, you're offered greater protections the more people that are using these things. Do your research, let's see, Tor best practices. Yeah, like we said, use the pre-configured settings, don't change them. Use an operating system that's designed to access Tor. So when you're, like, let's suppose you have Windows and you're like, I'm going to download Tor browser bundle. There's all these extra settings. Windows does all this crazy shit in the background, and it's really like, I can't make heads or tails of it, and neither do I want to. So instead, I'm going to use something like Wonix or Tails, which is designed and pre-configured by default to get you on Tor without compromising yourself and doing all the good things that you want. Windows and Mac, just don't use it. Like, we'll talk about this a little bit more. Get a USB thumb drive, put a Linux operating system on here that's designed to get on Tor, like put Tails on here, and when you want to use the dark web, you're going to plug it into your computer, or maybe like someone else's computer, not even your own, and you're going to boot off that operating system, and it'll take care of all the pre-configurations, and then you don't even have to, like, leave your Mac behind. You can still keep your Mac. Let's see here.
Would you in general say that it's not good to use Mac or Windows?
It depends. Like, Mac's probably okay, Windows are okay for certain things. I just believe they're backdoored, like Windows Spy. Like, Windows 10 was an obvious just ploy by them to start collecting even more data. Like, I don't think that if you're running Windows necessarily, someone's going to be able to hack in there and steal all your crypto. Linux is more secure in certain areas, and other areas it's not. Like, some people might tell you, oh yeah, run Linux, there's no viruses. Well, yeah, there's no viruses because no one's using it, right? Or like very few, like 1% of the population is using it. It's like Mac back in the day. Mac was like, oh yeah, there's no malware for our computers, but it wasn't, sure that was the case, but yeah, no one's using your computers right now. So now there's all kinds of viruses for Mac. So the same thing would happen with Linux if people started using it more.
Well, it should also be noted that Windows is just fundamentally less secure than Unix-based operating systems because of permission.
Yeah. So one of the big things that actually does make Linux far more secure is Windows. So it's something called root access. Remember that kernel we talked about, that lower level? The ability to access those lower level files at a very, the base of your operating system. That's closely guarded by Linux. If you want to make any changes to that, you've got to put your password. There's always a pop-up. But with Windows, there might not necessarily be any pop-up that asks your permission. Mac, I'm not really familiar with Mac. I've hated Mac for a long time. They're good in terms of usability, but I just hated how it seemed like they were trying to exclude my ability to transfer files from their system to anything else other than a Mac. But I mean, I think they're probably pretty secure. Like, they're a good product in certain ways. But I don't know. I don't want to tell anyone here, don't use Mac, don't use Windows. But don't use Mac and don't use Windows. Let's see. Again, risk versus reward. If you're doing some really crazy shit on the internet the government might hate and get you in trouble, then like go somewhere, leave your cell phone behind, go to some random place, plug in your Tails USB to a computer you'll never use again, whatever. Okay, so overall, like the idea about this is a mindset. You want to make it a habit to just stop and think for an hour or so, and how could I compromise myself? What are the things that I'm not quite clear on that I don't understand? If I wanted to do this thing, how would I do it? And just before you start using some of these tools, the more nefarious ones like Tor, just think ahead of time and think what your risks, what your purpose is. Okay, we're at the very end here. Bitcoin, I don't need to tell you guys what Bitcoin is, but I have some thoughts on it that maybe you haven't heard before. So governments can't agree on what Bitcoin even is. If you ask the Commodities Future Trading Commission, the CFTC, they're going to tell you it's a commodity, right? Now they're trading futures of Bitcoin on the CFTC, on the CME. The IRS says it's property. The SEC calls crypto equities, and Japan has made it officially a currency. So which one of them right? Which one of them is right? Well, none of them, because ultimately, remember we said that encryption is fundamentally speech. Bitcoin is exactly the same thing. It's just a messaging system. It's just a bunch of people connecting to each other and sending encrypted messages with digital signatures. It's none of, like, maybe it operates as those other things as well, but first and foremost, it's speech, which is why I think even within the framework of the United States law, they don't have any authority to regulate it because it's human readable text. You can print it, you can send it, and humans can read it. So that's just an interesting thought, I thought. And also, here's a good thing to keep in mind. Bitcoin was not the beginning of digital signatures or encryption. It wasn't the beginning of peer-to-peer networks, and it wasn't even the beginning of taking a database, doing a hash, and linking your hashes together, which is how you, that's kind of what a blockchain is, right? You have one block, you hash the block, it's linked to the next block, right? So on and so forth, so that you can verify the whole chain. That wasn't even the first time that, Bitcoin was not the advent or the origination of hashing a database to verify the state of it. And so what I did personally when I got into Bitcoin was I started learning about these things. I said, we can have private keys to do stuff, and I'm confusing that with blockchain, right? Oh well, I can make my blockchain, and I can have private keys to access this data, and we could even have a digital signature. Thinking conflating that with blockchain. Blockchain is composed of all these little components, but these components have existed for 20 years almost now, most of them, even longer in some cases. So just know that blockchain has a really specific purpose, and it's censorship resistant and digital scarcity. If you don't need censorship resistance, then you don't need a blockchain. If you don't need digital scarcity, in other words, well, we won't get into digital scarcity. I don't have any good graphics on it. And the last thing we'll talk about is chain analysis. Know that if you've ever broadcast a Bitcoin transaction from an IP address that is known to be yours, or from even hardware that's known to be yours, chain analysis can pretty easily, pretty robustly figure out who you are and which addresses are yours with a pretty high level of confidence. So Bitcoin is, we used to talk Bitcoin is anonymous. It's not really anonymous anymore. It's not even really pseudonymous. Yeah, it never was. People just hadn't developed the tools to do the analysis. So as far as I can tell, the only really good privacy crypto that keeps your anonymity safe, if you do all the other things right, is Monero. People ask me about other coins, and maybe there's some other coin as well that does as good a job of Monero. But you have to understand that blockchain and crypto is not just a tech. It's not just a science and some cool code. It's also composed of the network of all the people who use it. So Monero sort of has a network advantage. In addition to having really good tech, they've also got a really good community. I won't get into too many more of the details versus Monero versus name your privacy coin, Zcash, Zencash, and all these other ones, Gren, Beam. But if you're looking to try and be more anonymous with your crypto transactions, what I would recommend you do is again, use one of these little USBs. This is the easiest way to get started with Linux. Just put your operating system on here. Keep your computer how it is, right? Don't even change your current operating system. install Tails or something. And what you want to do is take your Bitcoin, use it to buy Monero over the dark web, and then you can transfer all that back into Bitcoin. And once you do that, no one knows. So right now you have Bitcoin addresses, and probably chain analysis knows who every single one of you are. So transfer that into Monero, do a couple transactions in the Monero system, and then transfer back into Bitcoin. And the Bitcoins that you receive from some anonymous person on the dark web, those are going to be basically washed. They're not going to be tied to your actual identity anymore. We're not going to really go over like how to do that, but that's like the idea behind what you want to do. There's information out there. Bisq, B-I-S-Q, is a really good decentralized trading platform that by default operates over Tor. It's the only one that I can find that's actually like 100% decentralized, that is not stored on some kind of server somewhere. There's not a help desk. It's kind of like Bitcoin. There's no help desk for Bitcoin. There's no corporation. Same thing with Bisq. You can actually do that, yeah. Obviously, you'll be de-anonymizing yourself, but yeah. Yeah, exactly. And I think, okay, this slide is only half done. But when I'm evaluating crypto projects, I like to look at a few things. Was it launched fairly? Are there founders rewards? Like, are the founders taking 20% off of every block? Or did they do some crazy pre-mine where they like pre-mined half of the coins right out the gate? Like, I don't want to make some other guy rich just because they pre-mined some coins. The other thing is, like, Bitcoin has no controlling foundation or corporation. It is truly a grassroots, community-driven project. And so I just don't want to see a corporation controlling my currency. The whole point of Bitcoin was that we don't have corporations and banks controlling our currency. Let's see, other things. Grassroots funding. Yeah, I guess I got lazy on that slide, but we'll send out a list of references and resources so that you can do more research. Hopefully this has been useful for you guys. Any questions?